There's a moment in nearly every classroom on Earth where a teacher says something like this. Of course, people used to think the world was flat. It's said with a little smile, a little condescension, the same tone you'd use to describe someone who thought thunder was angry gods bowling. It's one of the most repeated facts about the ancient world, and it might also be one of the most confidently wrong things most people believe about history. Because here's the strange truth hiding underneath that smug little classroom anecdote. The vast majority of educated people in the ancient world, going back over 2,000 years before Columbus ever set sail, knew the Earth was round, not suspected, not guessed, knew with mathematical precision, demonstrated proof, and in at least one case, a number for the Earth's circumference that was startlingly close to correct. So if ancient scholars had already worked this out with shockingly accurate math, where on Earth did the flat Earth myth come from? Why does practically everyone alive today believe medieval people thought ships would sail off the edge of the world? The answer involves a few real flat Earth believers scattered across history, a wildly popular work of historical fiction, a scientist with a grudge, and one of the most successful pieces of historical misinformation ever created. Let's start by demolishing the myth properly, because the actual history is more interesting than the cartoon version everyone learned in school. The ancient Greeks are where this story really begins, and they got there remarkably early. By around the 6th century BCE, philosophers including Pythagoras were already proposing that the Earth was spherical, partly based on aesthetic reasoning, since the sphere was considered the most perfect geometric shape. But the idea quickly moved beyond philosophy into observation. Sailors had long noticed something curious happening at sea. As a ship sailed away from shore, it didn't simply shrink into the distance the way a flat surface would suggest. Instead, the hull disappeared first, vanishing below the horizon while the mast remained visible. Then the mast itself slowly sank from view. That's not what you'd expect on a flat plane. It's exactly what you'd expect on a curved surface, where the horizon itself blocks the lower portion of a departing object before the rest of it. Anyone who spent time around ships in the sea, which in the ancient Mediterranean world was an enormous number of people, had access to this observation. It wasn't an obscure scientific data point locked away in a university. It was something fishermen and merchants could notice for themselves. Aristotle, writing in the 4th century BCE, laid out several separate lines of evidence for a spherical Earth, and his reasoning still holds up today as a genuinely solid scientific argument. He pointed out that during a lunar eclipse, when Earth passes between the sun and the moon, the shadow Earth casts on the moon's surface is always curved, regardless of the time of year or the position of the Earth relative to the moon. A flat disk would cast a flat, line-shaped shadow at certain angles. Only a sphere casts a curved shadow consistently, from every angle, every time. Aristotle also noted that travelers moving north or south observed different stars appearing and disappearing from the night sky, and that the North Star itself appeared to sit higher or lower in the sky depending on how far north or south you traveled. That's precisely what you'd expect if you were moving along the surface of a curved planet, changing your angle relative to fixed points in space. None of this required telescopes, satellites, or modern instruments. It required careful observation, logical reasoning, and people willing to write down what they noticed and pass it along to others. But the single most impressive piece of ancient evidence comes from a man named Eratosthenes, the head librarian at the Great Library of Alexandria sometime around 240 BCE. Eratosthenes had heard reports that on the summer solstice, in the city of Syene, far to the south of Alexandria, the sun appeared directly overhead at noon, casting no shadow at the bottom of a deep well. On that same day, in Alexandria, he measured the shadow cast by a vertical stick and calculated the angle of the sun's rays at just over 7 degrees from directly overhead. If the Earth were flat, the sun's angle should have been identical in both locations on the same day at the same time. The fact that it wasn't told him something profound. The surface of the Earth itself was curving between the two cities. Using the known distance between Alexandria and Syene, combined with that 7-degree difference, Eratosthenes calculated the full circumference of the Earth. His estimate landed somewhere around 25,000 miles, depending on which ancient unit of measurement modern historians use to convert his figures. The actual circumference of the Earth is just under 25,000 miles. A man with a stick, a well, and some careful trigonometry, working more than 2,000 years ago, got remarkably close to the correct answer using nothing but observation and mathematics. This wasn't some fringe marginal idea either. Spherical Earth became the standard, mainstream scientific consensus across the Greek and later Roman intellectual world, and it stayed that way. When Roman culture absorbed and built upon Greek scholarship, spherical Earth came along with it. Writers like Pliny the Elder, Ptolemy, and countless others simply treated it as established fact, the same way a modern textbook treats the Earth orbiting the sun. There wasn't a raging public debate about it. It was settled science, as settled as anything got in the ancient world. And critically, this knowledge didn't vanish when the Roman Empire fell. This is where the popular narrative really goes off the rails, because the story most people absorb involves a kind of dark age where humanity collectively forgot the Earth was round, plunging into centuries of flat Earth ignorance until brave Renaissance explorers rediscovered the truth. That's almost entirely fiction. Medieval European scholars, working within monasteries and the earliest universities, continued to teach and discuss a spherical Earth as basic, uncontroversial knowledge. The widely used medieval textbook on cosmology, written by a scholar named Johannes de Sacrobosco in the 13th century, opens with a straightforward explanation of why the Earth must be a sphere, complete with several of the same arguments Aristotle had made over 1,000 years earlier. Thomas Aquinas, one of the most influential theologians in medieval Christian thought, casually referenced Earth's spherical shape as obvious background knowledge while making entirely unrelated theological arguments. Dante's Divine Comedy, written in the early 14th century, structures its entire cosmic geography, hell, purgatory, and heaven, around a spherical Earth, describing characters traveling around its curved surface in ways that only make sense if both the author and his audience understood the planet to be round. You don't build an elaborate poetic universe around a scientific concept your readers have never heard of and would find confusing. Educated medieval Europeans understood Earth's shape just fine. So where did the myth actually come from? The answer involves a genuinely fascinating chain of historical misrepresentation, and it starts, somewhat ironically, with the story of Christopher Columbus himself. In 1828, an American writer named Washington Irving, the same author behind The Legend of Sleepy Hollow, published a heavily fictionalized biography of Columbus. In it, Irving invented a dramatic scene in which Columbus, preparing to sail west toward Asia, has to defend his expedition before a council of ignorant churchmen who believe he'll sail off the edge of a flat world and fall into oblivion. It made for compelling dramatic storytelling. It was also almost entirely made up. The real historical debate around Columbus's voyage had nothing to do with the shape of the Earth. Educated critics of his plan understood perfectly well that the Earth was round. Their actual objection was about its size. Columbus had drastically underestimated the Earth's circumference, using flawed calculations that made the distance to Asia look far shorter than it actually was. The scholars who challenged him were in fact working with numbers closer to Eratosthenes' ancient calculation, and they were right that Columbus's plan, as conceived, wouldn't work the way he claimed. Columbus got lucky. He ran into an entire pair of continents nobody in Europe knew existed, and that accident saved his expedition from the genuine flaw in his math. Irving's fictionalized version of events, however, stuck in the public imagination far more powerfully than the actual historical record, and the dramatic image of a heroic Columbus battling flat Earth ignorance became baked into popular American culture. The myth got a second major push later in the 19th century from two influential but deeply flawed historical works, a book by John William Draper and another by Andrew Dixon White, both writing in the latter half of the 1800s, pushed a narrative framing the entire history of Western civilization as a long dramatic war between science and religious dogma. Within that framing, the flat Earth made for an irresistible symbol. A supposedly ignorant, superstition-bound medieval church holding back the forward march of scientific truth, eventually defeated by brave rational thinkers. The problem is that this narrative required medieval Europe to have actually believed in a flat Earth, which, as we've covered, it simply didn't. White and Draper weren't being deliberately dishonest so much as building a compelling ideological story and reaching for evidence that fit the narrative they wanted to tell, evidence that turned out to be considerably weaker than they presented it. But their books were widely read and widely cited, and the flat Earth myth they helped cement found its way into textbooks, encyclopedias, and eventually classrooms across the English-speaking world, repeated by teachers who had themselves learned it as established historical fact, with nobody along that chain bothering to check the primary sources closely enough to notice the story didn't hold up. Now, none of this means literally nobody throughout history ever believed in a flat Earth. A handful of genuine flat Earth believers have existed, scattered across different time periods and cultures, and it's worth being precise about who they actually were, rather than overcorrecting into a different oversimplified story. A small number of early Christian writers in late antiquity, including a figure named Lactantius in the 3rd and 4th centuries, did argue for a flat Earth, partly based on a literal reading of certain biblical passages describing the Earth with corners or as resting on pillars. But these views represented a minority position even within their own religious and intellectual context, regularly contradicted and criticized by other Christian scholars of the same era who accepted the standard spherical model. There's also a genuinely separate question worth addressing, which is what ordinary, uneducated people across history actually believed, as opposed to trained scholars and astronomers. This is harder to know with certainty, since the historical record overwhelmingly preserves the writings of educated elites, rather than the casual beliefs of illiterate farmers and laborers who left no written record behind. It's entirely plausible that plenty of ordinary medieval people never thought carefully about the Earth's shape one way or another, simply because it had no practical bearing on their daily lives, the same way plenty of people today couldn't accurately explain how a vaccine works at a molecular level, despite living comfortably within a society that accepts the science. Not actively believing something is different from actively believing its opposite. So why has this myth proven so durable, so resistant to correction even once historians thoroughly debunked it? Part of the answer is that it serves a genuinely satisfying narrative function. It lets the present flatter itself at the expense of the past, painting a clean, simple story of ignorant ancestors and enlightened descendants, when the real history is considerably messier and less flattering to modern smugness. The truth, that ancient and medieval scholars were doing careful, rigorous observational science, using nothing but sticks, shadows, eclipses, and trigonometry, and arriving at remarkably accurate conclusions, doesn't fit nearly as neatly into a story about humanity's steady upward march from darkness into light. It suggests instead that intelligence and careful reasoning have existed throughout human history, expressed through whatever tools and knowledge happen to be available in a given era, rather than humanity simply getting smarter, generation after generation in some inevitable, linear progression. There's also something worth sitting with in the fact that Eratosthenes calculated Earth's circumference to within a small margin of the actual figure, more than 2,000 years before satellites existed, to confirm it directly. He never left Egypt to verify his result. He never saw the curve of the Earth from space. He worked entirely from a well, a shadow, a known distance between two cities, and an understanding of geometry that anyone willing to learn the underlying mathematics could replicate today. That's not a story about a primitive, superstitious ancient world stumbling in darkness. That's a story about the genuine power of human observation and reasoning, applied carefully, even with the most basic tools imaginable. The flat Earth myth tells us less about what ancient people actually believed, and considerably more about how easily a compelling story can outrun the actual historical record, especially when that story flatters the people telling it. Ancient humans weren't waiting around for modern science to rescue them from ignorance about something as fundamental as the shape of the world they lived on. They figured it out themselves, with sticks and shadows and careful attention to the sky, and they got it right.